All right, so before I get started, my company's name is actually Blue Ally. He said Blue Alley. It's okay, it's a common mistake. So good morning, everyone. My name is Dan Wade, and today I'll be talking about a network automation domain that I think is a little underrated, but I think it really should be the start to many people's network automation journeys, and that's network testing. Perfect. All right, wrong green button. So who am I? So I work at Blue Ally. We're a complete solution provider. So we do everything from selling hardware, services, consulting. We have a managed services end too. So we kind of do everything in between for your IT solutions. What my role is, particularly being a practice lead, is I help develop, I help sell, and I help implement automation solutions. So I get to kind of see the full life cycle of what network automation solutions that we sell, and that get to see it in client environments. So I kind of get to see kind of the full gamut there. My spare time, recently I'm a Cisco Press author. Wrote a book about Cisco PyATS, which is a network testing solution. My co-author is here, John Capobianco, somewhere. If you don't know who it is, he's probably the tallest guy in the room. He's about like 7'10" or something. So yeah, he's in the back there. I also do some blogging and YouTubing, and DevNet Dan is kind of my social handle there. So I like to bring it back to like the whole point we're here, right? Why aren't we seeing network automation adoption, right? Obviously it's being developed. We have people. Everyone in this room, most people in this room have developed some sort of automation, whether it's a small script to connect to a device or full-blown automation systems. So the automation's there. And most companies have some sort of procedure, guardrails, as I like to say, to implement changes, implement standard procedures or new processes. So we're able to develop it, we're able to, we have the framework to implement at these organizations, but why aren't we seeing adoption? And that kind of, along with many other reasons that we've talked about up to this point, having buy-in from others within the organization, culture. I think one of the biggest reasons is the lack of confidence we have in actually executing our automation and being able to kind of advertise it to the other parts of the business, right? And some of the symptoms include not having a true test environment. I mean, don't raise your hand unless you want to, but how many of you actually have a test environment that's not production, right? Good. I mean, that's great to see. But along with not having a test environment, if we don't have a test environment, a lot of times the pressure is on engineers to go out and deploy this automation in production. So you really, really want to make sure that your automation is doing what it's supposed to do, right? And so that's where you start having that doubt of, well, hopefully it executes as it should. And so you start kind of losing confidence, right? Because you want to make sure it's absolutely perfect, because you don't have that test environment, right? And the last piece being able to execute it in a standard maintenance window without having to worry about kind of going over or, hey, I could have done this just manually, right? So what I mean is execution deficiencies. I'm talking about, hey, I wrote automation, but it goes box by box by box, and I hope that the config sticks, or I hope that whatever I'm configuring works box by box by box, and at the end of the maintenance window, that I actually see the results I'm seeing. You hear that sometimes that there may be, you execute and go through an 8-hour maintenance window, and your automation takes 4 or 5 hours of that maintenance. Well, you quickly have to figure out whether it worked or not, because you have to take that 4 or 5 hours to roll back whatever you pushed out. So that's kind of where the code execution deficiencies may come in, and that's not all the time, right? That really is up to whatever the programmer or the specific tool that you're using. And I had to post the meme. I'm very surprised. I know Phil Drossi is up later, and I know he's full of memes, but I had to create one just to show kind of my thoughts and around automation, especially in the very beginning of automation, right? This meme kind of encapsulates my thoughts of a lot of times configuration, deployment, and service provisioning, which Chris, solidified with his survey results he showed yesterday. Configuration deployment, survey provisioning, or service provisioning was 2 of the top use cases for automation, what we're using it today. So a lot of times we find that use case in pushing configuration, and we have that value, right? There's a value that the business needs, a configuration push. Let's say there's some sort of new feature that needs to be pushed out, or hey, Black Friday's coming, we have to scale out our services. So there's that value, which then creates buy-in. So pushing configuration makes sense from a business perspective, but we shouldn't ignore the very easy, simple, low-risk ways of extracting data from the network and validating the network is running as we expect it. So why network testing? If you don't get anything else from my talk today, this is a quick, too long didn't read from my talk. Network testing has minimal risk. You are not pushing changes, you're not making any changes to your environment. You're simply extracting data from the environment and making assertions against that data. With that, you get a wealth of data, right? We had some talks about how we're starting to look at AI and ML solutions and being able to kind of wrangle in that data and get some results and analyze. And so being able to pull all that data from the network is so valuable. And last piece, and we have a few vendors here this week talking about this subject, is assurance. And this is where you have validating that the network is operating as you expect, and then it also introduces the idea of regression testing, which we'll be talking about here in just a second. And testing isn't new, so I'm not here to tell you or sell you on some new shiny product or a new methodology or something that just came out last year, right? Testing is not new, especially in the software space. So let's learn about what's been established for many, many years, right? So in software testing, I have a few different concepts within software testing. We'll start with the first one, unit testing. So unit testing, and some that develop code obviously probably heard of this, but unit testing basically take a function and validate that the output is expected or what you expect it to be. And so if you translate that to something in network testing, take something that's locally configured on a device. It could be an ACL, it could be a syslog configuration, it could be NTP. It's a combination of not just configuration data, but operational data. And you're validating that it looks as it should on the device, right? And like I said, it's localized. Integration testing, that is where you're starting to look at how does multiple systems talk together, right? So in networking, you're looking maybe at connectivity, routing tables, forwarding tables. You're seeing how devices are communicating with one another, not just at the local level. And then you have end-to-end testing. And this is, I think, everyone's favorite, where you start utilizing your handy-dandy tools of ping, traceroute. You may use a tool like iPerf for performance testing. You're looking at the full gamut where you're going from point A to point B across your network. And the last piece, regression testing. This is where, and this is very important, you check whether when you implement a new feature or you introduce a change to your network that you're not breaking something else. So in software, it's very common to do regression testing because you introduce a new feature, you introduce a new framework, you don't want it to potentially conflict or have problems with another framework or another version of a tool. So regression testing with the network, we all do all the time with all of our change windows. We validate the network looks one way before the change, and we validate it looks the same way after, or close to it, right? So being able to run those validation tests, we're doing it now, sometimes in a manual fashion, sometimes in an automated fashion. So now we kind of understand why we're doing network testing, why we would want to. We talked about some of the concepts and things we've learned from the software development world. So let's talk about implementing. This is a very basic graphic where it just talks about our thought process and basically our change management and the way we do things now. We capture a snapshot of the network before a change. We implement a change. We capture a post snapshot, and we do a comparison. But the important piece is what that snapshot actually means, right? In a snapshot, I'm not giving a definition, but it's however you define how you capture that network state. Some will capture configuration data, some will capture read-only, like show command output, and put it in text files and do comparisons. But what does that actually mean, and how can we actually get that data? So I kind of made my own definition, and I call it a guiding light, hopefully for many, is a snapshot really should be a normalized data model that consists of data structure that consists of operational data and also configuration data. And I think a lot of times we focus too much on one or the other, but being able to capture both the intent with the configuration, but then how's the network actually running? Getting that into one data model. And why I mentioned normalized data model, so data normalization offers the three main benefits that I just posted here is there's better data organization, you have less data, less data redundancy, and you have more data consistency. So what that means is, think about this. If you're in a change window and you capture show, command output, or read just the operational state from, call it 3 different Cisco devices, an Arista device, a Juniper device, you have a bunch of different data points. And if you're using any, whether it be parsing libraries or available Yang data models, if they're vendor specific, you may have the parsed data may look different. It has all the information you need, but it's all different as far as being able to parse out particular keys, or I'm looking for a particular value. So getting that into a normalized data set where you're able to say, okay, here's my entire state, getting it all into one data structure that then you can parse through and do your validations and assertions. That's the key of a snapshot. However that looks to you, that's kind of, that would be the ideal state. So here's some different ways. I put together a different list of getting that data, right? I mean, this should be, some of these methods and libraries and things that I'm mentioning here should be very common, and tools that you've used and that I've personally used. So by far, I think the most used, being the lowest common denominators, CLI scraping, and using different tools such as Nornir, NetMiko, Scraply, your text FSM, parsers, being able to scrape the data from the CLI and being able to parse it and do your comparisons. That's still, I think, one of the top use cases. Hopefully, moving away from that, we're looking more towards the second bullet point, which is a true API. It's a way, APIs are basically a contract that allows systems to communicate, and there's many different APIs. The two most common, I think, I would say from the list I provided is REST and GraphQL. I apologize if you like SOAP APIs. Obviously, I'm not a big fan, but REST and GraphQL, I think, are two of the top. And talking to vendors here, I'm sure if you ask, hopefully they answer, yes, we have an API available, especially today's day and age. So beyond applications, though, the network and network devices are starting to have a true API, and that's provided by Yang data models and netconf, restconf, GNMI. So not all devices support the same Yang data models. There's different Yang data models. So if you know Yang, you know what I'm talking about. If you don't, it's definitely an interesting world. But it is a good effort to get to that standardized data structure I'm talking about, to where you can efficiently and effectively parse the data. And you don't really have to get all your information from the network. You can take information from tools that you already have implemented. So I mentioned a couple open source tools down here at the bottom there. We have a network source of truth, like a Netbox, Nautobot, InfraHub, right? That provides that context for your test. So you can pull information from tools within your tests, so you don't have to pull all this stuff from the network and then do your static mapping or anything like that. You get as much context as you can from the tools that you have. Another good tool is SuzyQ. I know Dinesh is here. SuzyQ is an amazing tool to help with the lift of pulling all that data from your network. And it also exposes the data with popular Pandas data frame, a very popular data analysis library. So you're able to get all that data, have it normalized, and extract it from a tool like SUSEQ, which helps, like I said, lift some of the effort of getting that data from the network. And then you have a configuration analysis tool like Batfish, which if you were part of, I believe one of the workshops implemented Batfish to do configuration analysis. You can use all these tools to get to the data points and make the assertions that you want within a testing framework. So now let's start talking about testing frameworks. So as I touched on the beginning, software testing has been around forever. So I'm going to touch on a couple of Python's testing frameworks, as Python, I think, is the leaders with network automation. I know Go is becoming more popular as well. But to touch on Python, we have unit test, which is part of the standard library, and we have PyTest, which is preferred in my opinion. It's external to the standard library. However, it has a really cool plugin ecosystem that you can create plugins for almost anything. And we'll actually touch on one that's focused just on networking. So transitioning from Python testing frameworks, I call these Python network testing frameworks. So I have PyTest again because there's a really cool plugin integration called NUTS, Network Unit Testing System. If you haven't seen that, it's an open source project on GitHub. Highly recommend checking it out. And it helps create that structure and integration with PyTest. And you can create test definitions and test bundles and helps you get started. And I like to call PyTest, if you're familiar with Python web frameworks, I like to call it the Flask of network testing. It allows you to bring your own, whatever that may be. It has a lot of flexibility, but you have to bring your own device connection library. You have to collect your own data. You have to bring your own parsers. So if you're familiar with the NetMiko, the Nornirs, the TextFSM, it provides a lot of flexibility because you bring that to PyTest. PyTest is just bringing the scaffolding of the testing framework, right? The second testing framework is Cisco PyETS. Cisco PyETS is what I like to call a batteries included framework. It has everything from the testing framework to the parsers to the device connection library to even the reporting. All of that's bundled together in one library. And so you don't have to go out and figure out all the different pieces, right? So not saying one is better than the other, but whatever fits your use case, right? If you're already developing automation, PyTest may be flexible enough for you to integrate other tooling or other scripts that you've already built. And then the last one here, ANTA, so Arista's network test automation framework. If you haven't heard of it or haven't seen it, highly recommend checking it out. I've seen demos of it and I've tried a little bit myself. Have not used it in any of my projects or with clients yet, but it's a very interesting framework and it's very a well-built framework. And this is not an inclusive list. Hopefully don't take this and say, all right, there's only 3 network testing frameworks out there. This is just based on my experience. So let's talk about PyTest. I mentioned it's flexible. I mentioned it's the Flask of network testing. But some concepts that you should be familiar with are assertions. So assertions are validating this value should look like this, or this value is greater than or equal to this, right? It's your simple comparison. So that's your pass-fail results. Then you have your markers. Markers are really interesting because it allows you to tag tests and based on certain tags, customize the behavior. So NUTS, the plugin I mentioned, actually utilizes markers to do some of its functionality. So the markers are very interesting. And to give you a quick example, it allows you to, for example, skip a test based on a result of another test or on a condition that you see fit. Fixtures, so fixtures we'll actually dive deeper on. Fixtures are really cool because it allows you to share context among different tests. So a good example in software testing, maybe you have a test database or a dev database that you always use for testing. You take that database connection object and you use it across all your tests. So you instantiate it once and you use it across your tests. You don't have to recreate it for every single test and have multiple connections and so forth. And maybe you want to for load testing or whatever, but if you're just trying to connect to a database and get some data, it would be more efficient just to instantiate it once. So fixtures are very interesting in that piece, and it also allows you to share and create mock data for your tests. So if you have like a JSON payload or anything like that where you want to share or fit it into a test, fixtures allow you to do that. And the last piece is parameterization. So this allows you to loop through multiple parameter sets. So a good example I like to use is, let's say you have a function like adding two parameters. So A and B get fed into an add function, return A plus B. But let's say you want to add C and D and E and F. So you could basically create, I call it basically a parameter set where you feed in multiple sets of parameters and you hit against the same function, right? So you're reusing one function, but you're feeding in different parameters. So that's parameterization. And Cisco PyATS. So PyTest, those were some of the concepts from PyTest that being familiar with will be very helpful. Cisco PyATS, like I said, it's a batteries included framework, so you have everything kind of built in and baked into that library. So you have a test bed, which is essentially an inventory. You can define beyond just the devices. You could define links and interfaces between devices. You could really create a whole network topology within a test bed. You have the AE test infrastructure, which is your testing infrastructure. So think of it as the scaffolding for creating your test cases and your setup and cleanup and everything that's involved with testing. You have Unicon, which is the device connectivity library. The PyATS library, which I know sounds very confusing, it is separate. It was formerly known as Genie, so if you've ever went to a Cisco Live and heard of PyATS and Genie, Genie is now called the PyATS library. Very confusing, so sorry about that. That does all your data parsing. EasyPy, which takes care of all your runtime environment and your reporting. So think of if you had multiple test scripts with test cases and you wanted to run them simultaneously, EasyPy has got you on that front. And then there's a bunch of other features I won't be able to touch on, but definitely recommend taking a look at all the different features within the PyATS library. So some success stories. So I think at this point, I've talked about why we should do testing, some of the testing frameworks, some of the importance of testing, the different components that make up the framework. So let's talk about actual success stories that I've been a part of and projects that I've been a part of. So the first one. So this one, we were implementing network access controls at the port level, and so pushing configuration, and we had to ensure that the site was operational. These maintenance windows were anywhere between 30 and up to 60 switches, right? So it wasn't just one site, a couple switches, and hope that it works. This was, we pushed configuration and we validated that the ports didn't shut down, that certain features were enabled, that counters looked okay. I mean, we did a few different tests within this particular project. So we used a mix of Nornir and PyTest. So Nornir was our task automation tool. And so the reason we chose Nornir is it provides some flexibility with some business logic that some other tools couldn't provide. So we used Nornir and PyTest for the testing piece. We created multiple fixtures, and these fixtures were used to set up Nornir. So basically the Nornir object allows us to instantiate an inventory, do the configuration. We instantiated that once, and then we actually fed it into another fixture which filtered our device inventory for that particular maintenance window. So we had one fixture that just got the Nornir objects up and running, and then we had a separate fixture that filtered to the device inventory and the devices that were for that maintenance window. And then we had the last fixture took that Nornir object, that filter Nornir object, and ran tasks to collect data. And all these tests were executed. They validated command output, but they also validated configuration. So here's a very simple kind of overarching workflow of what PyTest and how we utilized it. So we created fixtures that collected the network data And so we had the network data, whether it be a big JSON payload, XML, whatever it might be, and we fed it into our tests, which then did all the parsing. The reason we did this is because we don't want our tests worrying about going out and getting the data and having error handling and all the problems that could come with connecting to a device and collecting the output. We did all this in the fixtures, which all execute before the test. So the tests, all they had to worry about was parsing the data and then running the assertions. Here's another graphic of kind of what I just talked through with the fixtures. Essentially, like I said, we created the Nornir object. We fed that into another fixture, which filtered our device inventory just a little further to the, 40 to 60 switches that we were hitting during that maintenance window. And then what we did was we used that one fixture and used it across other fixtures to execute Nornir tasks, which then collected the operational data and the configuration data and so forth. And so how did testing look? So you can see, it may be tough to read, but the blue box on the left, that is mostly, those are all the fixtures that we created and then used within our test. So you'll see like the middle, the second fixture down, we actually use across multiple tests, right? And then you'll see the results. This isn't exact. This is kind of a summary of what the results kind of look like. But essentially, we tested the environment. We tested for port security. We looked at the config, right? And then we validated that the operational state of the port security looked good. So we looked for shutdown ports. We may have found some that were error disabled. And then lastly, we also looked at DHCP snooping counters and the operational state of that for the network access control project. So very quickly, we could see the output. And you may say, well, that's cool. I can see like the test, everything looks good, 100%, no failures. But I can't hand that to a client. We were able to, you can utilize the plugin framework that I mentioned earlier to output to an HTML file or more presentable ways. And so you can create plugins with PyTest to basically augment what that output looks like. But this is kind of what your terminal output looks like for most PyTest. So success story number 2, this is a project where it was with a long-standing client. We're doing hardware refreshes across multiple sites a week across a multi-year period. So this is a very long project. The project, we have already built a configuration generation tool for this client. Right? So we were already generating configs. We knew some of their standards. But then we started asking, well, how are you guys validating? And it ranged from engineers saying, well, yeah, we capture all the output, throw it in Notepad, and attach it to the ServiceNow ticket, of course. And it's like, okay. You talk to another engineer, and they're like, yeah, we do that for the important sites. Okay. So we've quickly learned that, okay, this is very inconsistent, right? We don't know how they're capturing the data. They're manually parsing this by reading through that output, whatever that might be. We quickly figured out they needed some sort of testing framework in place. So we utilized Cisco PyATS, and we built tests, over 46 different tests, and it's been over a year now, so I imagine it's well over 50 different tests. But we have tests that included environmental checks, CPU memory, power. They were very interesting. We actually wanted, there's a show command to look at like power for Cisco devices. They were very interested in validating, hey, the power supplies are operational, the fan state's okay. They wanted to look at all that stuff. Obviously monitoring tools can help, but in the, when you're during a change window, you want to be able to just in time, checking these stats. And so we had all these different tests that we built, and they were very particular, just for the particular. And it was real easy because the SOPs that they were supposed to run, right? All the commands and the validation checks, all of that was very well documented. So we basically just took those and translated it into code and performed these tests. The tests themselves were selected based on device type. So we had layer 3 tests, we had layer 2 tests, and then we had a common base test that ran across all of our all their devices. The artifacts generated included a pass-fail quick check, hey, pass-fail results, and then also we gave them all the device logs. That's one thing I can take away from that project is We were able to build trust with the engineers that were performing this manually by providing the same amount of detail they were used to, but then also automating the parsing and the checking that they hated. So, but they still got the device logs, so that way they can do their own checks as well if they felt that something was off. So here's a quick workflow of how that application looks. So this was actually a Flask application. So it was a web app. They had a portal with a form, filled out site and device information based on the form information, and they had an internal system of record that actually was well spot on, and we were able to use the form data with the system of record and generate a PyATS test bed. We were able to select the test cases based on what's called groups in PyATS. So we basically tagged each of the test cases with that L3, L2, common, or base. And so we were able to go through, tag, and say, okay, well, based on all the inputs that we got, these are the ones we want to run. And so we used the groups to run those tests. We executed them. We created the summarized HTML report for the engineer, and then we provided the results that they could then download and attach to the ServiceNow ticket. So quick comparison between the two. I touched on PyATS and PyTest, or Nornir and PyTest, I should say. PyATS, it's a testing framework. It's based on concepts from both PyTest and unit test. The documentation states it as well. If you go through and learn PyTest and you learn a bit about unit tests, PyATS will be very easy to understand, and you'll start seeing the similarities. As I mentioned, it's batteries included, so you have the parsers, the device connection library, all that's included. It is, I meant to touch on it earlier, PyATS is a vendor agnostic library. I know it has Cisco in the name, but it does have support for Junos, Arista's EOS, and it does have Nokia SROS as well. So, and plenty others, but those are the top ones I definitely wanted to get out there, because I think a lot of people see Cisco PyATS and think, oh, it's just a Cisco product. Reporting and archiving is also included with Cisco PyATS. So, and in comparison, PyTest, very flexible. Bring your own. So, like I said, if you know automation and you have some scripts or you have some knowledge about some libraries that you want to run tests or collect data to run tests, PyTest would probably benefit you. And it does require a deeper understanding of PyTest and the concepts I mentioned at a high level. You kind of have to dive a little deeper to be able to utilize and work most efficiently with PyTest. And then the plugin framework, like I said, it's undefeated. The plugin framework with PyTest just, I think, makes it so great. So one thing I wanted to do, and this was something that I think is very important. I talked this whole time about network testing and how great it is and how you guys should get started. And one thing that I wanted to put together was as I mentioned in the beginning, John Capobianco and I wrote this book on Cisco PyATS, one of the frameworks I just talked about. So this isn't paid by Cisco in any way. I actually worked with Cisco Press myself, and I got a few copies. I got 3 copies of our book that I want to give away. It's just for the people in this room. So the QR code that's up there, you'll get to a landing page that has a Blue Ally logo. So Blue Ally is the company I work for. They provided the landing page. If you want a chance to win one of the 3 copies, we'll go ahead and register. John and I didn't even know John was going to be here, so it's very cool. So you'll actually have a signed book by John and I, but we'll give away 3 copies so that way you can get started on your network automation journey with network testing. So that's all I have. I'll start taking some questions.
So a lot of your use cases were focused on kind of user-driven test automation, right? We've had that for years, the diffs and all those things. We've always had that. What we're trying to work towards now, and I'm wondering if you have any use case or experience doing this, any feedback, is how do we integrate test-driven architecture into automation? So I need the automation to be able to kick off the validation, consume the results, and either automatically roll back and things like that. And so we're spending a lot of time trying to think, how do we design kind of a results engine that can be programmatically and systematically consumed.
Right.
And PyTest doesn't do that very well, right? It produces an HTML report, right? So.
Right, okay. Yeah, so I'll take it from the, so I'll use PyATS as an example. So PyATS has a really good reporting and archiving feature where it will take all the data and put it in basically JSON or XML. You could then take that output, let's say a test ran and you wanted to basically do something based on an action of, run an action based on the results. You could parse that output of the return results, whatever that might be, to kick off that next event-driven workflow, whatever that might be. So there are ways through basically reading through those reports and being able to parse those reports for particular values to then kick off another workflow. So the key is taking the results and getting it into a way that you can programmatically interact with it. And so that way you could either parse it being JSON, XML, whatever that might be. And PyTest, I don't know about all the different plugins that they have for the output, but I'm sure there's a way that you can get it into a fashion where you could take the output and parse it and then make actions based on whatever output that is.
I use PyTest to do software, not network. And there is a learning curve, and a lot of this needs a lot of work to set up. Do you have some of these layer 2, layer 3 tests and device-based tests already pre-written? And setting up fixtures and all this is one part, right? Writing tests is tedious. And
yeah.
So is there like some kind of template for these tests, or do you do it for each client or whoever you work with separately?
Right, so almost like a test library with, yeah. So we do, with the clients that we wrote tests for, yes, we do have our own tests. The interesting piece, and that goes back to kind of the flexibility, is there's so many different ways to do it that it would be tough to publish that library unless you have an opinionated way of actually parsing the data and doing the assertions. So yes, I think that is possible. I think we could do that for sure. It would just be, like I said, up front, we would have to say it's an opinionated way to parse the data. But yeah, I get what you're saying. Basically having something to say, hey, here's a bunch of different tests. This is how you would check for these different features. So that's a good idea, yeah. But to answer your question, we do have them for our clients and engagements projects that we've completed. Oh, right here? Okay. Sorry,
Yeah,
I didn't know I was pointing. Sorry. Yeah, go ahead.
Great talk. I think I have two questions. The first one is related to what I think I just heard, which was, what are some strategies you've seen in making sure the fixtures are up to date with the operational data?
The fixtures are, so the fixtures are what's getting the operational data. What you're asking, I guess, is the tests that use the fixtures if, let's say, the schema or something changes. Good point. So in that case, probably, obviously, version control. If you, let's say, use an external library like the popular, like NTC templates, you'd obviously have to make sure if you upgrade your parsing libraries, whatever that may be, changing your tests to the schema. Or what you could do is take that parsed data, create your own data model that stays uniform that the tests use. So that way you're not changing the tests all the time. All you're doing is feeding in your data model, whatever that may be. And you could use a popular library like Pydantic or something to create that data model. But you feed the parsed data into Pydantic, and then you feed that into your tests. So you're not changing your tests all the time. You may just be changing your model or how you parse that data.
Okay, and that's related to the operational data that is being mocked.
And that was going to be my follow-up. You could also use mock data as well, yeah. You could just use mock data, and that way you know what the data structure is, and you know how it will always look.
Okay, and
so,
then quick, then the second question would be, how much and where do lab environments play a role in testing, for network testing? Can you do it without a lab environment?
Depending on your organization, I would say yes, you can, because it is just running a bunch of show commands. So if you have the ability and you have the permission to any time of day or specific windows to run show commands in your environment, that's all it's doing at the end of the day, right? As if we're talking about CLI parsing, now if you're interacting with other APIs and whatnot, obviously you have to have the right permissions. But for me, I like to keep everything kind of close. So like I utilize like Container Lab and other tools to really validate my whole workflow before I would, release it to production per se. Yeah.
Yeah, question. A lot of the examples of the tests you gave are isolated to the device that you made a change directly on, validating that it came up and it's running on that. How many of your tests do you explore, and specifically not post-change or production validation, but before the change, digital twin gets thrown out? Like, what's the size of the digital twin you normally do? I mean, network, everything's connected, especially once you get to the WAN, but where do you find that line to draw or decide, hey, I'm going to spin up just the 3 local switches or just the adjacent ones, or do you spin up the entire site and that kind of impact to test, what it may be affecting outside of the device itself?
Yeah, that's a good question. So my personal experience, I haven't used any sort of digital twinning, right? Most of mine are just with testing with either operational data or mock data. I would say that goes just back to risk analysis, right? So with the client, I would work with the client if they have a digital twinning, a tool that can produce, digital twinning. Being able to work with them on identifying, hey, if I hit these couple HQs, is that something that you want me to run through this process or create automation to do that? So I would say that's considered, I would put that in the design phase of whatever project we're part of, is identifying what those higher risk sites or higher impact sites are, and then maybe creating additional kind of I don't want to say testing around it, but you're almost creating an extra barrier of, okay, these tests are as they say they are, and will minimize the risk.
Well, that's time.
Okay, cool. All right, thank you guys.